8 numeric value questions from the section Binomial Theorem were asked in the January 2024 session of Joint Entrance Examination Main Mathematics. These examinations were held from 27th January 2024 to 1st February 2024. We now discuss the solutions of the first 4 numeric value questions from the section Binomial Theorem. Now, we first go to the first question. This question has appeared in the JEE Main exam held on 27th January 2024 in the second shift. The given question is the coefficient of x to the power of 2012 in the expansion of 1 minus x to the power of 2008 multiplied by 1 plus x square whole to the power of 2007 is equal to. So in this question, we have to find the coefficient of x to the power of 2012 in this expansion. Let's now discuss the solution of the problem in detail. We have 1 minus x to the power of 2008 multiplied by 1 plus x square whole to the power of 2007. We split this 1 minus x to the power of 2008 as 2 factors. One is 1 minus x and the other factor is 1 minus x to the power of 2007 multiplied by 1 plus x square to the power of 2007. Now 1 minus x multiplied by 1 plus x square is 1 minus x cube, and for each one of them the power is 2007 is there. Therefore, it will be equal to 1 minus x into 1 minus x cube whole to the power of 2007. Right. So, for this 1 minus x cube whole to the power of 2007, we write down its binomial expansion. How do we write the binomial expansion? This is equal to sigma r is equal to 0 to 2007 minus x cube to the power of 2007 minus x cube to the power of 3r minus x cube to the power of 3r, where r varies from 0 to 2007. Right. So we have taken care of minus x cube. Therefore, this is written as minus 1 to the power of r into x to the power of 3r. Multiply. So this is sigma minus 1 to the power of r into x to the power of 3r. This is for the 1 minus x times. That will be sigma minus 1 to the power of r plus 1. Why? Because here is also a minus. Minus 1 into minus 1 to the power of r is minus 1 to the power of r plus 1 into x to the power of 3r is x to the power of 3r plus 1. What is that we want? We want the coefficient of x to the power of 2012. So, we ask a question, for what values of r belongs to n, the set of natural numbers, x to the power of 3r is equal to x to the power of 2012, or x to the power of 3r plus 1 is equal to x to the power of 2012. That is, for what values of r belongs to n, 3r is equal to 2012 or 3r is equal to 2011. Now that means is 2012 divisible by 3? Is 2011 is divisible by 3? No. Note that 3 divides neither 2012 nor 2011. Why? because the sum of the digits is not divisible by 3. That is the rule for that divisibility condition. So note that 3 divides neither 2012 nor 2011. Therefore, we do not have a term containing x to the power of 2012. Therefore, its coefficient is 0. There is no term containing x to the power of 2012 in the above expansion. So the coefficient of x to the power of 2012 in the expansion is 0. Right. The answer to this question is 0. So that is the detailed discussion of the given question. Now let's move to the next question. The question number 2. It has appeared in the JEE Main exam held on 29th January 2024 in the first shift. The given question is, if 11C1 by 2 plus 11C2 by 3 plus etc. plus 11C9 by 10 is equal to n by m, with GCD of n comma m is 1, that means there is no common fact between n and m, then n plus m is equal to. The question is self-contained. Let's move to the solution. Let's now discuss the solution of the problem in detail. Now 11C1, 11C2, 11C9 etc. are appearing. So we will take the expansion of 1 plus x to the power of 11. Use the binomial theorem. You will have expansion is sigma r is equal to 0 to 11. 11CR multiplied by x to the power of r. Agreed. Expand it. 11C0 plus 11C1x plus 11C2x square plus etc. plus 11C10x to the power of 10 plus 11C11x to the power of 11. Look at the question. 11C1 by 2, C1 by 2, C2 by 3, C9 by 10. So that means the denominator is more than, if it is CR, it is R plus 1 sitting in the denominator. So how do we get this? This we get it by integrating. So integrating on both sides with respect to x, between the limits 0 to 1, we will have integral 0 to 1 plus x to the power of 11 dx is equal to integral 0 to 1 of the entire binomial expansion is to be integrated with respect to x. Now if you integrate the left hand side, it is 1 plus x to the power of 12 by 12. Right. To be evaluated between 0 to 1. And on the right hand side, integral of 1 is x plus 11c1, integral of x is x squared by 2 plus 11c2, integral of x squared is x cubed by 3, so on and so forth. So the last term we have written as 11c11x power 11 as 11c11 is 1 only, 1 x to the power of 11. So when you integrate, it will be x to the power of 12 by 12. Right. To be evaluated between 0 to 1. So for the left hand side, 1 plus 1, that is 2 to the power of 12 minus 1 plus 0, 1. 1 to the power of 12 is 1. So we'll get 2 to the power of 12 minus 1 by 12 is equal to x between 0 to 1 is 1 only. This is 11c1 by 2 plus 11c2 by 3 plus 11c9 by 10, 11c10 by 11 plus 1 by 12. Agreed. But look at the given one. So that is 11c1 by 2, 11c2 by 3, 11c9 by 10 only. That means what happens to this 11c10 by 11? So that's what we're asking. 11c10 is 11c1. 11c1 is 11. 11 by 11 is 1. So we will have all that. For this, we write 1 plus 1 by 12. Now we want this one. We want this. So that will be, this will imply 11c1 by 2 plus 11c2 by 3 plus etc. plus 11c9 by 10 is equal to the left hand side, that is 2 to the power of 12 minus 1 by 12 minus 1 minus 1 minus 1 by 12. Now take the LCM and simplify. You will get 4070 by 12, and there is a common factor, namely 2 is a common factor. Cancel that. Now there is no common factor between the numerator and denominator. 2035 by 6, there are no common factors. So if this is n and the denominator is m, since there are no common factors except 1, so the GCD of n and m is 1. So this is equal to n by m. There are no common factors. Therefore, the GCD of n comma m is 1. So n is 2035, m is 6. We want n plus m. So now n plus m is equal to 2035 plus 6 is equal to 2041. The answer to this question is 2041, and that is the detailed discussion of the solution of the given problem. Let's move to the next question. That is question number 3. This question has appeared in the JEE Main exam held on 29 January 2024 in the second shift. The remainder when 64 to the power of 32 to the power of 32 is divided by 9 is equal to. We have to find the remainder of 64 to the power of 32 power 32 when it is divided by 9. What is the remainder? So that's what we want to find. Okay. We now discuss the solution of the problem in detail. 64 to the power of 32 to the power of 32. This power, that is 32 to the power of 32, we take it as n. Okay, we take it as that. So then that will be, now 64 to the power of 32 to the power of 32, it will be 64 to the power of 9. This 64 we write it as 8 square, that is 8 square to the power of 9. That will be equal to 8 to the power of 2n. Because we have to find the remainder when divided by 9, this 8 we will write it as 9 minus 1. This will be equal to 9 minus 1 to the power of 2n. Now we apply the binomial theorem, write down its binomial expansion. This will be equal to sigma r is equal to 0 to 2n, 2n cr into 9 to the power of 2n minus r multiplied by minus 1 to the power of r. Yes. Yes. Expand it. 2 9 c naught, 9 to the power of 2n plus 2n c1, 9 to the power of 2n minus 1 into minus 1 plus etc. etc. 2n c 2n minus 1, 9 power 1 into minus 1 to the power of 2n minus 1. This is the last but one term plus the last term minus 1 to the power of 2n. Agreed. Now first term as it is, the second term will be with a minus sign, right? The third one is plus, the next minus, and the last but one term is also minus, because minus 1 to the power of 2n minus 1 is minus 1, because 2n minus 1 is odd. So 2n c8 2n minus 1 into 9 to the power of 1 plus 1. Minus 1 to the power of 2n, 2n is even, therefore minus 1 to the power of even is plus 1. Now we have written down this one in the brick red color. Yes. Observe that in each one of them 9 is there. 9 is present. Even the last but one 9 is present. That means each term is divisible by 9. Each term is divisible by 9. That means each term is a multiple of 9. So when you subtract and add and so on and so forth in this brick red colored one, then you will get it's a multiple of 9m plus 1. Now 64 to the power of 32 to the power of 32 is a multiple of 9 plus 1. Now when you divide by 9, it will be, the remainder will be 1 only. The remainder will be 1 only. So the remainder when 64 to the power of 32 to the power of 32 is divided by 9 is 1. The answer to this question is 1. That is the detailed discussion of the solution of the given question. It is a simple and straightforward question. Now let's move to the last question in this discussion. That is the fourth question. This question has appeared in the JEE Main exam held on 30th January 2024 in the first shift. The given question is the number of integral terms in the expansion of 7 to the power of 1 by 2 plus 11 to the power of 1 by 6 whole to the power of 824 is equal to. So you have to expand this. In that expansion, you have to find out the number of integral terms. That means the terms which are integers are called integral terms. So how many of them, how many of the terms of this expansion are integers? We now discuss the solution of the problem in detail. So let us write down the general term of the above expansion. That is TR plus 1 is equal to 824 CR into 7 to the power of half 1 by 2 to the power of 824 minus R into 11 to the power of 1 by 6 to the power of R whole to the power of R. That is equal to 824 CR into 7 to the power of 824 minus R whole by 2, right, into 11 to the power of R by 6. Now 824 CR is an integer, is a positive integer, and the 7 to the power of 824 minus R by 2 will be an integer if 2 divides 824 minus R, and 11 to the power of R by 6 will be an integer if 6 divides R. So combining these two, this will give you integers, positive integers, if 6 divides R. So to obtain integral terms, we must have R is divisible by 6, or 6 divides R, R is divisible by 6. So now the summation in the binomial expansion will be R is equal to 0 to 824. So from R is equal to 0 to 824, what are those R which are divisible by 6? They will start with 0, 6, 12, 18, so on and so forth, What is the last term in this one? Less than or equal to 824 divisible by 6, that is 822. So look at them. R belongs to this set. So 0, 6, 12, 18, etc. 822 is in arithmetic progression whose first term A is equal to 0. Common difference D is 6. Let us say the number of the terms is n. So let n be the number of integral terms in the expansion, and the n is given by A plus n minus 1 into D is 822. A is 0. N minus 1 into D is 6, 822. That will give you n minus 1 is equal to 822 by 6. So when you divide, you will get 137. Therefore, n is equal to 137 plus 1, 138. Therefore, the number of integral terms in the given expansion, is 138. The answer to this question is 138. And we have now come to the end of the discussion of all the first 4 questions, numeric value questions, that have appeared in the January 2024 session of JEE Main Mathematics examination from the section Binomial Theorem. Right. I am sure that you have understood the solution of this problem. I am sure that you have understood the solutions of all these 4 examples, and I wish you all the best. Thank you.